Welcome to part 1 of Competency 8. For this competency, a teacher should understand exponential and logarithmic functions, analysis of their algebraic and graphical properties, and uses them to model and solve problems. This competency is still part of Domain 2, which is the 33% of your grade. In this video, we will answer questions relating to the exponents and logarithmic functions. I have two lists of exponential rules and logarithmic rules that you will need to refresh your memory on. If you want to, of course, stop the video and take yourself a screenshot, or you can look them up online or in a book, or maybe they're in your old notes. But this is a list of the items that we will use throughout this video and also the next video after this. Okay, number 1, how is the expression 3 to the negative 4 equals 1 over 81 written in logarithmic form? That means as a log function. Okay, so already you should know from your rules of logs and exponents, or rather exponential rules also. So here, let me pull this down where my pen, okay, now my pen shows up. Okay, so 3 is the base of the log. Okay, the exponent 4 becomes the answer or the value that the log function is equal to. And that is not spelled right. I'm not sure what I was doing. Okay, there you go. That's a lot better. Not sure what I was thinking. Okay, and this 1 over 81 actually is the argument. So then we just need to put everything into the correct position. The first thing is 3 is the base. Well, where does the base go? It will go here, like a lower number in that position, okay? All right, so none of these work, okay? And then 81 is the argument, which goes after that, okay? And then the answer obviously would go after the equal. So the only option that truly works is C. The others just have everything in the wrong, incorrect. The minute you saw that the base wasn't in the correct position, it's easy to see that which one is the correct option. Okay, so let's look at number 2. Okay. If log of Q equals Y and log of R equals Z, write an expression in Y and Z that represents log of Q squared over R. Okay, the first thing that we need to remember, and you can see from your options that this is true, is that we're subtracting. When you see division, you know you have this. You know you can take log Q squared, okay, and subtract. Because remember, it says an expression. So we're just doing expression. We don't need a whole equation. Okay, so then that is minus, the log of R. See, because it's the denominator, so that's what you're subtracting. Log of R. Okay, so then what does this represent? Well, let's look at this, okay? So that means that also following the laws of logarithms, this first term actually also is equal to 2 log of Q. They're equivalent, okay? So then we still have log of R, okay? So now let's break this down into the given. Okay, this is given and this is given, okay? So this means we have, this would be Y, and then this would be our Z. So this gives us 2y, 2y minus z, okay? All right, so which one does that work with. Not this one, not this one. Oh, it looks like C is the only option that's correct, okay? All right. It's just you have to apply all the rules. So if you miss a rule, for example, log of q squared becoming 2 log q, that completely gives you a different option. Okay. So this is pretty much the fact. If you're not familiar with the rules of exponents and logs, then you really need to make yourself very familiar with them because they will be used in practice test and the actual test. Okay, number 3. What is the value of x in the equation log x plus 6 equals 3 log 2? Okay, for this particular one, okay, we know that we can. Okay, let me show you what we need to do. This rule that we had where we took the exponent down, for this purpose, for our purposes here, we need to put the exponent back. Because once we have these two logs equivalent, then I'll show you what we can do, okay? All right, so let's say log x plus 6 equals, okay, now put this back, log of 2 to the third, okay, because those are equivalent. So now in this form, okay, we can drop the log. It actually works. So then we have x plus 6 equals 2 to the third, okay. So then we just solve like, okay, well, we know what 2 to the third is. That's 8. So at this point, we can just solve it like, just a simple algebraic equation. So if we subtract 6 on both sides, what do we really have? We have x equals 8 minus 6 equals 2. And that gives us our value of b. Okay, let's go to number 4. What is the value of x in the equation 2 log x equals log 4 plus log x plus 3? Okay, we can rewrite the first expression and call this log x squared, okay? And then we set that equal to. Now remember, what's really happening? When we're adding these two together, that means that we can multiply these two together. The arguments are multiplied together. So this gives us log, oh goodness. Here. Okay, computers have it. Oh, there it goes. Delayed reaction. All right. Okay. So log, I'm going to put it in brackets, 4x times x plus 3. Okay, now that you see that we have log on both sides, we can drop the log. Okay, so what do we have? We have x squared equals 4x plus 3. Okay, I am not going to distribute or do anything else. Let's use our numeric solver. Okay, so what do? We need to push math, okay, but you need to arrow up. So you get C, okay, which is a numeric solver. Push enter. Now, we have x squared, that's E1, okay? So this is E1, and this entire expression on the other side is the E2. So arrow down, clear this out, and I'm leaving it in parentheses exactly how I have it. 4 parentheses, then x plus a 3, close the parentheses. Now, see where it says OK and graph? I push the graph. And you have to push solve sometimes once or twice, but in this case, only once. So what do we have? D is our option. Now, if we followed through and solved this, we would get two values. We would get x equals -2 and x equals 6. Well, The solver gave us 6 because it is the only valid answer. The -2 is not a valid answer in this situation, okay? All right, so now let's back out of that and we're going to move on, but we're going to use this again. Okay. All right, so let's look at number 5. What is the value of x in the expression log 5 plus log x minus log x minus 7 equals log 8? Okay, so what we need to do is get the constant logs with the constants together. So we are taking this and moving it to the other side by subtracting minus log 5 from both sides. Okay, so now we rewrite that, okay? All right, so we actually have now log x minus log x minus 7 equals log 8 minus log of 5. Okay, so this tells me when you're subtracting, you have to divide. But what we're going to do is pull out the arguments because we can just drop the logs because each of our terms has a log. They are a log. So that tells me we can drop them. Okay, so what do we really have? We have x over x minus 7. I'm going to put that in parentheses for a reason. Okay, and then we have 5 over 8. Okay, now we can use a solver, but you can't use a solver in the form that it's in. And you can't solve it by hand either. So what do we need to do? We need to multiply both sides by this x minus 7 in parentheses. So multiply both sides. X minus the 7 and x minus the 7. And what happens? These cancel out. Okay? So this is what we're going to put in the calculator. X is our E1, and then the 8 over 5. Now, I want that in parentheses. And x minus 7 is my E2. So let's put that in the calculator. Push math, arrow up. See that solver? Push enter. Okay, there we go. Now it's clear. All we have on one side is just x. Then arrow down and let's clear that out and start over. So parentheses, 8 divided by 5, close parentheses, open parentheses, and x minus the 7, close parentheses. And you have to push the graph button, graph, and twice. You have to push it twice. And that is the value that we need. Now, from our ABCD answer, we can see that that absolutely has to be 18 and 2/3. However, if you're not sure, let's say you have other very close answers, very close decimals, and you're not sure what that would be equivalent to, you can do this. You put in 18 point and push as many as you can, enter. That way it resembles the repeating, just like what the calculator would spit out. Okay, so now what do? Well, you push alpha fraction, put it in fraction form. Math, not alpha. Alpha's next. Math number 1. Okay, so number 1's highlighted, enter. Enter again, and that gives you a fraction form. Now we push alpha window, and we arrow over, and it's number 3 is what you want. 3 bounces them back and forth. All right, so let's push number 3 and enter, and there you get your exact form. Okay, I've done that in other videos. I don't always like doing it. If I really know what the value is and I know what the correct option is, I don't like pushing a bunch more buttons. That's me. You may want to double check more complex rational number in the mixed form. And then you would apply that. It's completely up to your situation. Okay, now what do we have here? Okay, what we're going to do this is condense that logarithm form, and then we need to talk about what the log really means. So what do we have? Well, when we're adding, we're multiplying, right? So we have log of x times x minus 15 equals 2. Okay, and we can, you know, distribute that. But before we distribute that, let's talk about this. There is something that you may not know if you're not familiar with logs. If you are, you already know what's going on. This right here between the log and the brackets, this item in brackets, this is an argument. Well, hang on a second. If that's the argument, okay, and we're in that form, go back to your rules of logarithms, okay? All right, you can look this up, or even your exponential. Look at your exponential of your rule. Okay, this little highlighted area, that is the base of your exponent. And what goes in there? This is an understood 10. When you're putting log in your calculator, you're actually putting in an understood 10. Well, if that's the base and the brackets is the argument, then this too must be the exponent. Okay, so how would we really honestly write this? Well, this is what you do. The argument becomes the answer. So we have this. We have 10 squared equals the argument. Okay, well, when I rewrite, I'm going to rewrite this by distributing. Okay, I'm going to go ahead and just do that. Right, so that would be, okay, x squared minus 15x. Okay, all right. Okay, let's try this in our solver. It should work in this form. Let's see what happens, okay? All right, so we say math, arrow up. It's highlighted on C, push enter. Okay, so let's clear this out. So we say 10 squared. Arrow down, clear it out, and we have x squared minus 15x. Uh-oh. X squared. Ooh, not sure what I pushed. I need to pay attention. Minus 15x. Double check our entry. It looks correct. Now, where it says OK, you push the graph button. Okay, and remember, you might have to push it twice, but it looks like it's done it for us. So that value is 20. So the valid answer would be C, 20. Now, yes, when you solve this as factoring, like it's a quadratic. So when you factor the quadratic, you will get two different values. Okay. You'll get 5, -5, and 20. Well, the -5 is not a valid answer for this question, and that's why you only get the 20. Okay. All right. Let's go to number 7. What is the value of x in the expression 6x equals 3? Okay. Well, I'm going to solve this with natural logarithms because that's simply just how I do things. And you need to have that skill. Okay. So there's also another way to do it. You could do, actually, let's just do this. Okay. All right, so we could say that, okay, we have the base is 6, right? So let's do this. We have log of 6. The argument is 3, and the answer is x. Okay, well, how would you do that? How would you put that in the calculator? Well, you put log of 3 over log of 6 equals x, okay? All right. Now, the other way to do that, well, I like to use the natural log. I don't know. It's just a habit I have. Rarely do I use log, okay? But they are interchangeable. So this is what I do. I am going to set those both as logarithms, okay? So what do I actually have when I do that? Well, the equivalency, if I use ln 6, I bring down the 3. Remember that exponent, if I have the exponent here, it's equivalent, okay? So here, let me erase that real quick. So I'm going to go ahead and just do that. Okay, so that would be ln 6 equals ln 3. Now, oh, I'm sorry, that's not a 3. Oh my goodness, that's an X. Okay, and my pen's not, okay, there it is. I saw 3 and I put 3 on both sides. That's completely not right. Okay. It's an X. Okay, this is correct. Now, on both sides, you will divide by ln 6 to get your X alone. Okay? The ln 6 on that side cancels out. So what do you really have? X equals, look, you have the same thing. It doesn't matter which way you do it, you end up with the same result. So let's put this in the calculator, okay? Okay, we need to back out of what we had, right? And you can use log or natural log. I'm going to use the natural log, okay? So I have natural log of 3, close my parentheses, and divide that by natural log of 6, close my parentheses, and it equals 0.613. I mean, no, 0.6131. And yes, option B. Okay. All right. Let's go to number 8. Number 8, what is the approximate value of x in the expression 7x plus 2, the x plus 2, so exponent, equals zero point 0.5, a half. So you will apply the natural log or log to both sides. I favor natural log, okay? So what happens when we apply that, okay? We can bring down the x plus 2, and then we have natural log of 7 equals natural log of 0.5, okay? So what we need to do is divide both sides by natural log of 7, okay? This cancels out. Okay, so, well, what we really have here is subtract both sides. At this point, just subtract both sides by 2. Okay, so we can just subtract by 2. You know what? I'll rewrite this so you actually see it. Okay, x plus 2 equals natural log of 0.5 divided by natural log of 7 minus 2 from both sides. Subtract that. All you have left over here is the x, and this is what you put in the calculator. Okay? All right, so, I mean, you could have used a solver, I suppose, but at this point, why? Why bother, Okay, so let's say natural log of 0.5, close the parentheses, and divide by natural log of 7, close the parentheses, and I'm going to push enter and then subtract. Because if I say minus 2 right now, I know for a fact that I will probably have an order of operations situation. The calculator will not read it correctly. So push enter and then subtract your 2. Okay. All right. Yeah, I think it would have really messed up. Okay, let's look at our option. Option A has to be A. It is negative. Excellent. Okay. Now, if you want to play around with those, the parentheses and see if you can do it all together, what we would have done to make sure it would be okay is start with the parentheses and say the natural log of a half, then divide by the natural log of 7, close your parentheses again, and then subtract 2. And yes, and that'd be right. Yeah, you got to be careful when you're dividing and subtracting within one expression on one line in the calculator. It doesn't always like it. Okay, let's look at number 9. What is the approximate value of x in the equation e to the 3x plus 1 equals 10? Okay, definitely have to apply the natural log here. Okay, so what's really happening? Well, because we're applying the natural log, okay, we have 3x plus 1, okay, but then we're applying the natural log to e and the natural log to 10. This guy becomes what? And if that's not something that you've seen, just put it in your calculator. Natural log, and you need second divide, close the parentheses, and push enter. It equals 1. Very convenient, okay? So then what do we really have here? We have 3x plus 1 equals natural log of 10. Okay, now we subtract 1 from both sides. Okay, this goes away. But we also, let me rewrite that. We also need to divide by 3. Okay, well, we could do that all at once. Well, let's just go ahead and do it. I mean, we're not, high school students. I think we can understand what's going on. So we can divide both sides by the 3, and then this will go away. But be careful that you make note that you've got that x in there. So here, this whole thing should equal x, okay? All right, we can put that in the calculator as is, and we'll be just fine. Or, yeah, let's just put it in the calculator as is. All right, there's a couple ways to put it in. But now if you put it in like this, be careful. Use those parentheses because you have got a subtraction in there with the division and the natural log. You could have some problems. Okay, so let's just do that real quick. Parentheses, natural log 10, close your parentheses, subtract your 1, but you got to close parentheses again, and then divide by 3 and push enter. And there we go. It would be option D. Of course, all right, with a little bit of rounding. All right, let's look at number 10. Okay, all right. What is the approximate value of x in the equation 6 to the 8 minus x equals 1 over 216? Okay, we're doing the exact same thing we did before. Okay, so you bring down the 8 minus x, okay, then we have the natural log of 6. But we have to keep that because it doesn't just cancel out. Like, it doesn't just become 1 mysteriously. Okay? And then that equals the natural log of the 1 over 216. Right now, we divide both sides by the natural log of the 6, the ln 6, and then by the ln 1, oh, I'm sorry, ln 6 on both sides. Oops. Okay, let's let this takes a second. Okay, that's not annoying at all. Ah, there it goes. Okay, now let's go back. Okay, 6. 5 by 6 on both sides. All right, this cancels out. But if I rewrite that, things can get a little interesting here because we have that negative, okay? I'll go through the process. All right, so we have 8 minus x equals, I'll rewrite the whole thing. The natural log of 1 over 216. Natural log of 6. Now, we need to subtract 8 from both sides. There we go. The problem is we have a negative x on one side. Okay? Here, I'm going to make some room and let's talk about this real quick. Well, okay. So we have minus x equals, but we can't have the negative in front of the x. So what do? We could say we multiply both sides by the negative or divide both sides by the negative 1. It doesn't matter. What we know is if we take this whole thing, make this negative in front, then I know that becomes a positive because we're multiplying both sides by negative 1. So a negative times a negative is positive. Okay. All right. And if you could read my X there, that's a tiny bit better. Okay, so what are we putting in the calculator? Everything on the right side, all right? Okay, but we will have to use the parentheses to deal with that. Don't try to distribute the negative in. It isn't worth the headache. So say negative parentheses, okay? And I'm going to say parentheses again because we have this situation. Let me change colors here. We have this situation right here, okay? And we have a minus 8 after it. That will cause us problems also. So we need 2 parentheses and the natural log 1 divided by 216. Okay, now I push my division, natural log of 6, but I have to close my parentheses again. See, there will be 2. Okay, then subtract my 8. Okay, and then close my parentheses again. Let's push enter and hope it works. Otherwise, we can do it piece by piece. Okay, and it worked perfectly. The answer is 11. Yeah, that can get a little interesting. Okay, you could distribute the negative in and apply this separately. You know, it's totally up to you how you want to handle it. I just like to put everything in all in at once. Okay, this is the last question in the first part of Competency 8. Wanted to thank you guys for watching. I really appreciate the viewing and the sharing and all of the great thumbs up you've given. The liking and sharing is great. And the subscribing has been really nice. I really appreciate it. And once again, happy testing, guys.